Hello friends, welcome to Learn Max Easily channel and I am your tutor here to take about the lesson real numbers. What is the basic definition for real numbers? Now real numbers can be positive or negative. They are actually expressed by the capital symbol R. Now they are the union of both rational and irrational numbers. So what is this fundamental theorem of arithmetic states? This is the first topic that is being discussed in the real numbers chapter, the fundamental theorem of arithmetic. They have given certain basic examples over there. 7 into 11 into 23 is equal to 1771. So the 7, 11, 23 are all prime numbers, which we all know, positive prime numbers. So multiplying these positive prime numbers results to a composite number. Let me explain again. 7, 11, 23 are set of collection of prime numbers. Now if we are multiplying this as many times as we want, say for example 7, 11, 23, then even 2, 3, whatever it is in a set of events, if we multiply and the result which we obtain is actually a composite number. This is the actual fundamental theorem of arithmetic states. So 2 into 3 into 7 into 11 into 23 will result in 10,626 is again a composite number. So here they have explained in the theorem 1.1 as every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factor occurs. Like it can be of any order in which we multiply the prime numbers to get the desired composite number as the output value. So as I told you before, 2 into 3 into 7 into 11 into 23 are set of prime numbers which has been multiplied. The result which we get is 10,626. Say for example, by this theorem what we can analyze is multiplying, like as I telling, like 7 into 11 into 23 into 3 into 2. So this again yields the same output. You can just check it with the calculator. 7 into 11 into 23 into 2 into 3. Again we yield the same output as 10,626. There's nothing change in that. So that is being expressed over here. Okay. Now this theorem actually says that the given composite number can be factorized as a product of prime numbers in a unique way. So like say for example, the composite number which we arrived that last pack we got as, say for example, 1771. So by factorizing this 1771 we get the prime numbers 7, 11, 23. Over here we got 1771. Okay, this is a composite number. What they are telling is when we factorize this we get the prime numbers 7, 11, 23. So this actually a inverse of the fundamental theorem of arithmetic. When we factorize the net value, then we get the prime numbers which we multiplied before. So this is one of the fundamental theorem of arithmetics. Now let's we see the exercise 1.1. Express each number as a product of prime factors. Okay, so what are the questions which they are given over there? they have given as express each number as a product in prime factors. Yes, express each number as a product of its prime factors. So what they have given as 140 as its first question, and I kindly request you guys to have your textbooks in your hand uh, to have a better view of the questions that are being given in the textbook. So express each number as a product of its prime factors. First question is 140. Okay, now upon taking this 140 into the account, so we need to express this in the product of its prime factors. Okay, now the prime numbers, as we all know, that are 1, 2, 3, 5, 7, and it goes on. So 140 should be expressed in the product of these all numbers. So that's the first question that have been asked. Okay, how we can carry out this process in order to reach the answer? Okay, fine. We guys know that we can simply take LCM of this number which is been given over here. It is, okay, now 140. First we can move on with 2. What happens? It comes as 70. Then 5. What will be the answer over here? 1, 4. Then 2, 7, 7, 1. So we arrived here as 2 into 2 into 5 into 7 into 1. So this is the LCM which we got while we are doing the general LCM method for 140. So now the question which they asked is express each number as a product of its prime factors. So 140 is the first question they have been asked. So we have expressed the 140 as the product of prime numbers. What we did is, generally we took the LCM, we derived the values over here, we expressed this in a multiplication form that has been asked in the question. Okay, similarly, let's we work out with 156. Same way, we need to take 156. Again, we need to do the same format LCM. When it goes on with 2, it comes as 78. Then again with 2, it comes as 39. Now 39 cannot be divided by 2, so in order to go to the next value 3, we get over here 13. Then 13 again only divides by, or it goes by 13 alone, so we get the result output 1. So again the same process, 156 can be represented as 2 cross 2 cross 3 cross 13. So now we expressed again 156 in the product of its prime factors. Now the same process for the next upcoming questions that has been given in your textbook. Okay, fine. For 3, 3, 8, 2, 5. the same process which has to be carried out to arrive the product of its own prime factors, the numbers which we arrived for the last two sums. So first step, we are moving with 3, we get 1 2, so 7 5. Again we go with 3, we get 4 and 2 5. Again if we calculate with 3, we get 1 4. Okay, can we move on with 3? No, this cannot be moved with 3. So what can be the next number which can be moved with 425? 425 can be divided by 5. So let's we go with 5. With dividing this by 5, we get 8 5, right? Okay, 85. Again this 85 can be furtherly calculated with 5, we get 1 7. Okay, further this cannot be divided by any number because 7 is again a prime number. Okay, fine. So 3825 can be represented as 3 cross 3 cross 5 cross 5 cross 17. So this is the expressing a number as a product of its prime factors. Over here every number that has been present here are prime numbers. So I want you guys to try the next two sums that has been given in your textbook, and if you have any doubt with respect to those sums, you can again cross check the previous three sums which I worked out, and if two you can't understand, you just kindly post it in the comment section. I will post it in the upcoming other videos whichever possible. Okay, what does the second question actually tells? Find the LCM and HCF of the following pairs of integers and verify that LCM cross HCF is equal to product of the two numbers. Okay, what are the numbers being given? 26 and 91. Okay, what they actually speaking is we need to find the LCM and HCF of those two numbers individually. I mean, yeah, we need to find the LCM and HCF of those two numbers, and what they are asking is we have to verify whether the product of that LCM and HCF is equal to the product of the given two numbers. Okay, now for 26, they are asking us, and for 26 if we do the same process, we get 13 into 2 into 1. Okay, the same process we do for 91. For 91, what we get is 13 cross 7. The same method we have to try out here. See, 91, if we take it with 7, we get 13 because no other go to divide 91. So 13 cannot be divided further by any other number. So 13 can be divided by its own. So 13 cross 7. Same way for 26. 26 if we divide by 2, we get 13. If 13 is divided by 13, 1. So we arrived these two numbers. Okay. Yes. Now what they are asking is, see, we have got the multiplied value of given two numbers 26 and 91. So we need to find the LCM of 26 and 91 by the same method. So by, see, one of the easiest method, if I tell you, when you arrive this one, say when you arrive these two things, we can easily find the LCM value of 91 and 26 easily. See, over here you just write the values present. 2 into 7 into 13 is being repeated twice. I want you guys to write 13 only once, as because it has been repeated twice. When we take LCM, we get the same value. See, here 13 is present, here 13 is present. So with respect to these two, we can write only 113 value, and the rest of the value should be written on itself. Okay, so when we multiply this, what we arrive is 7 into 2 14, 14 into 13 we arrive 182. Yes, so LCM of these two numbers which we got, that is 26 and 91, is 182. Okay, HCF, highest common factor. So by this way, like the assigning or the thing which we calculated for 91 and 26, we got 13 cross 7 for 91 and 13 cross 2 for 26. By this itself, we can arrive that the highest common factor for these two is 13 itself, because 13 is common to both the numbers. Fine. So the HCF for 26 and 91 is 13 and LCM is 182. Okay, but what they are asking is, we need to verify if we product 26 cross 91, that should be equal to this 13 cross 182. That's the question they have been asked. Okay, let's check whether it is true or not. Okay, now what we need to do is 26 cross 91. We need to check what is the actual value. 26 cross 91, we get around 2, 3, 6 and 6. Okay, now according to the question, what we need to do is, we need to multiply the answer which we got, that is 182, our LCM value, and 13 our HCF value. Okay, fine. So what we arrive is the same value, 2366. You can check it up with your calculator, or you can do by your own mind calculations, or in your notebooks, wherever it is. You just cross check whether you get 26 cross 91 as 2366 and 182 cross 13 as 2366. Okay, yes. Now the condition which has been given in the question, we need to verify whether these two numbers are equal. Yes, they are equal. So the condition given in the question is being satisfied by these two numbers. Fine. So what we have to, we need to close the answer. That is, for this question we need to close the answer. So what we are going to write is, the product of LCM and HCF. See, the product of, you need to write this in the end of the answer. Product of 26 and 91 is equal to the LCM and HCF of 26 and 91. Okay, 1. Yeah, this should be your end answer after solving the entire thing. Okay, because most of the schools are expecting you guys to write the end result like this, or else many schools are just striking off your answer paper whether it is right or wrong. They won't see whether it is right or wrong. They expect this whole content in the paper. Okay, Yes. Okay. Now the same question for like 510 and 92, 336 and 54. We need to carry out the questions like same for this question which I did. Okay. If you want to work out, you can just do the same process which I explained for the first question, right? Okay. Now what does this third question actually speak about? Okay. Find the LCM and HCF of the following integers by applying the prime factorization method. Okay, they have actually given what is the method to be used for this thing, for to find LCM and HCF. Okay, prime factorization method. Okay, fine. 12, 15, 21. So on doing the prime factorization method, 12, for 12 we get for 12 in prime factorization we get 3 cross 2 cross 2, again like this one. 12 divided by 2 we get 6, divided by 3 we get 2. This 2 can be written as 1. Okay, fine. This way I have written over here 3 into 2 into 2. Then 15 can be written in the only way 5 cross 3. Then we have 21. 21 can be written as 3 cross 7. Okay, now what they have asked us is nothing but we have to find the LCM and HCF of the following integers by applying the prime factorization method, right? Again, by this we can come to the conclusion of HCF. As I told you, HCF can be come unto the conclusion of these numbers, as well as for LCM we can easily find the values of these both by concluding with these numbers, right? Okay. 3 cross 2 is for 12, 5 cross 3 is for 15, 7 cross 3 or 3 cross 7, whatever it may be, for 21. What is the common number in all these three sets? What is the common number we have? 3. So that will be the HCF, highest common factor. The name itself suggests common factor. So 3 is the common in all these three multiplied numbers. So our HCF for 12, 15, 21 will be 3. Okay, what about the LCM? Okay, as I told you before, see, first LCM, if we do whatever we can carry out with the general LCM method which we are being followed in our school, or simply don't waste your time, we can move on by this way. See, 7 is to be multiplied. Yeah, 7 is a single common term, we have to be multiplied that. Again 5 is a single, we have to multiply that. This 3 and this 3 will be cancelled, so the remaining 3 has to be multiplied. Okay, then we have to multiply the 2 cross 2 that is being present in the same set, so 4. Yeah, so upon multiplying these numbers we can get the LCM value, that is nothing but 420, right? So the question which they asked is, we need to find the LCM and HCF of the following integers by applying prime factorization method. First we need to apply prime factorization method and we need to arrive these values. After arriving these values, we need to find out the highest common factor in all these three. That is 3, because it has been included in all the things. So HCF is 3. It has been common to 12, 15 and 21. Okay, coming up to LCM, as I told you, the common factors have been cancelled and the remaining numbers are to be multiplied. So we get 420 as the LCM for 12, 15, 21. Okay, right. Okay, now we go to fourth question. What they have given is, given that HCF of 306, 657 is equal to 9. Find LCM of 306, 657. So this is again the same process which we need to carry out, but we don't need to take the HCF value, LCM value. We can easily find this by this method or a theorem which is being used in this chapter. It's nothing but HCF cross LCM is equal to product of the two numbers. Okay, they have given 306 as one number, 657 as another number, and they have given the HCF as 9. So with this formula we can easily calculate what is the LCM value by just merely multiplying these two numbers, and the result answer should be divided by 9. Okay, so what we are going to do is LCM is equal to 306 cross 657 must be divided by 9. So what we arrive by cancelling this with 3, we get 3, and it is 102. Again further dividing, we get 3, it is 3, then 4. So multiplying these two, we get the value as 2, 2, 3, 3, 8. So what the question asked is, what is the LCM of 306 and 657? It's nothing but 22338. Okay, yes. So we can easily arrive the answer if they have given HCF or LCM with the two numbers by this formula. Time has been saved by this for using this formula, and we get the correct answer too. Yes. What is the fifth question they have given is, check whether 6 power n can end with the digit 0 for any natural number n. That's the question that has been asked. So we have to check again. Okay, 6 power n. Now they are given 6 power n. We need to check that it can end. Say for example, n can hold any value like 1, 2, 3, dot dot dot, any value that has been substituted over here. Say for example 6 power 2, we get 36. So any number over here which we substitute, we need to get the result as at the end to be 0. Like the result number should be xxx 0. Okay, 6 power 2 is 36, 6 power 1 is 6, 6 power 3 is nothing but again 36 into 6, again it ends with 6. So what they are asking is, at any point it may be the 256, that is 6 power 256 or whatever it may be, at any point whether we get the last digit as 0 or not. We need to check that. Okay, how we can do that? So first let me clear the space to carry out the problem. Okay, how can we carry on, or how whether we know or not, we need to check out, right? Okay, now as I told you, 6 can be written as 2 cross 3 prime factorization. By the method of prime factorization, we know that 6 can be written as 2 power 3. Okay, what they have been asked is 6 power n. So nothing but I am just changing 6 as 6 power n. So the entire 2 cross 3 will be changed to 2 cross 3 power n. Understood? They have given 6. We can write 6 as 2 cross 3. What they have given, 6 power n. 6 power n again can be written as 2 cross 3 power n. Okay, this whole. Okay, yeah. Now the prime factorization, what they have asked, whether the prime factorization, that is the check, we can end with 0, digit 0. Yeah. Now whether if a number is being ended by the digit 0, it can be divided by the unit, like say this number ends with 0, say for example 100. It can be divided, or whether we'll do the prime factorization method or whatever it is, we need a number 5 in one of its places. Say for example 100. While we are calculating 100, we can do like 5 cross 2 cross 2. What we get is 20 cross 5. So in any one position we need the 5 for a number which has been ending with a 0, right? So over here we get 2 cross 3. There is no presence of 5 over here, so we can easily conclude that the 6 power n, this n can hold any value as I told over here. So the 6 power n cannot end with a digit 0 for substituting a natural number in its power value. It cannot end with 0 value at all. Whatever the number it may be, say for example 1000, it will never become a 6 power n parameter, or 10,000, it also never comes under 6 power n format. So they are asking us to check whether it can come. So our statement is we cannot, or like it is clearly understood that 6 power n, the number which has been analyzed or which has been arrived with the 6 power n, cannot be divisible, or it cannot end with digit 0 in its last place. Okay, yes. Now we need to rub these things. Yes, so as to go to the next question that has been given in the exercise. Yeah, fine. Now what is the next question that is being asked is, there is a circular path around a sports field. So okay, around a sports field there's a circular path. Okay, Sonia takes 18 minutes to drive one round of the field, while Ravi takes, oh, I missed the sixth question. Yes, explain why 7 cross 11 cross 13 plus 13 and 7 cross 6 cross 5 cross 4 cross 3 cross 2 cross 1 plus 5 are composite numbers. Yes, we need to work out this question, then we'll move to seventh one. Okay, what they have asked is 7 cross 11 cross 13 plus 13 is a composite number. Why? They are telling that it's a composite number. They are asking us to explain it as why. Okay, now, okay, before entering this question, what I want to do is, see, we need to check out the common factor in this and this. The common factor is 13. Okay, with respect to the common factor, what we are going to do is 7 cross 11 cross 1 plus 1. We can return by, or we can write this as this. Okay, yes. Now further we can easily simplify. 7 cross 11 is 77 plus 1, so it reaches us 13 into 78. Okay, 13 into 78. Yes, now it will be more easier for you to do the thing. That is, for 78 we can easily do the prime factorization method, and we can arrive the value 78. Upon dividing it with 2, what we get is uh, 3 9 39. With 3 we get 13, with again 13 we get 1. Okay, 2 cross 3 cross 13 is 78. Okay, now what we need to do is express this thing which we arrived. So 13 cross 2 cross 3 cross 13, right? This 78 is being expressed like this one. So for our simple or easiest route of calculation, we are dividing, or we are reducing the 78 to 2 cross 3 cross 13. We are, yes, we are reducing it. Okay, now what we have now in our hand is, okay, I'll just erase this thing. Yes, now what we have is 7 cross 11 cross 13 plus 13 is a composite number, is a composite number. Why? Okay, I just factorized, or I just divided, and I got this result, and I am concluding it as a composite number. Why? See, we know the definition that if a number is said to be a composite, then it has a factor of 1 and itself. We know that, right? We have seen that it has a factor of 1 and itself. So with respect to that criteria, I arrive that 7 cross 11 cross 13 plus 13 is a composite number, as because I got this, what to say, 13 and 13. Understood? Yeah, so I arrive this as a composite number. Okay, fine. Now we have another number that has been given. Okay, now erasing this. Yeah, the another number that has been given over here is 7 cross 7 cross 6 cross 5 cross 4 cross 3 cross 2 cross 1 plus 5. Now we need to check whether, like, this also a composite numbers, right? Yes. Now what we are going to do is, this 5 is present here as well as here. Again we need to take 5 as a common outside. So 5, it comes as, wait, I'll just rub this, it comes as 5 and 7 cross 6 cross 4 cross 3 cross 2 cross 1, right? Now this will come here. Okay, cross 1 plus 5, I mean plus 1 because 5 has been taken outside, right? Plus 1. Okay, I'm extracting, or I'm just taking out the 5 outside, so that is to be multiplied in both the sides. Now again I need to simplify this. I'll just rub this. I need to simplify this, so I'm multiplying the inside values. 7 cross 6 cross 4 cross 3 cross 2 cross 1. Again I arrive to a number 1008. Okay, 1008, and this plus 1 should be remained as it is. Now it is 5 cross 1009. Okay, yes, what the value we get is not needed, but by this what we can arrive is, see, 7, this value, the 7 cross 6, this value, that is the 7 cross 6 cross 5 cross 4 cross 3 cross 2 cross 1 plus 5 is a composite number, because when we multiply this we get some value. Okay, that value is again divided by 5. We can, right, we can obtain this number, or this value can be divided by this number, we obtain 5. So according to these calculations or these criteria, upon conclusions we get a certain number, right, that will be a composite number. So upon simplifying this, or 7 cross 6 cross 5 cross 4 3 cross 2 cross 1 plus 5 is a composite number. We can conclude it by saying, by writing this whole thing, and we can say it is a composite number, right? Okay, now okay, now we have another question, that is the seventh one. What they are asking is, there's a circular path around a sports field. Now Sonia, a girl, takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Now suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Okay, what, so like these word problems, I want, or what I do is, first jot down what has been given in the question, right? Now Sonia, sorry, Sonia and Ravi, right? Sonia and Ravi move in the same direction at same time, move in the same direction, right, at same time. Let me write as T. Okay, now what is that they are asking is, Sonia takes 18 minutes to drive one round and Ravi takes 12 minutes. So okay, moving in the same direction to complete the one round of the sports field, Sonia is taking 18 minutes and Ravi is taking only 12 minutes for that, right? Ravi is taking only 12 minutes. Okay, now what is they are asking is the time, the time when they will meet again at the starting point, the point which they started. Sonia has been running, Ravi has been running, and they are asking the time period when they both will meet at the starting point. By the question itself we can come to the conclusion whether we need to do LCM of these two numbers or HCF of these two numbers. Yes, no other go, we have to go with LCM, right, to carry out, to find the time which they are asking. Okay, so we need to do LCM of 18 comma 12. So what's the value of 18, LCM of taking 18 comma 12? The same method we need to do, right? What we arrive is, for 18 we get 2 cross 3 cross 3 into, for 12 we get 2, for 12, okay, wait, for 18 we got 2 cross 3 cross 3, for 12 we get 2 cross 3 cross 2, right? So for LCM what we do, we need to write the common values for 1 and the rest of the values as it is. So 2 cross 3 cross 3 cross 2, right? These 3 1, these 3 as it is, these 2 1 2, these 2 as it is, right? So 2 cross 3 cross 3 cross 2. So the result value which we get is 36. Okay, so what they are asking is, when will Sonia and this when will Sonia and Ravi meet again? So what the answer is 36 minutes. So after the starting, after like when starting after 36 minutes, this Sonia and Ravi will meet each other. Like Sonia and Ravi meet each other after 36 minutes of their starting point. Yes. So by this exercise is being completed. So I want you guys to go through this video for how much times you want, so as to have a clear understanding of each and every sum that has been worked out, and you carry out the sums. First watch the video, try to understand the full concepts, and without watching your classworks or your notes and this video, try to do all the problems that has been present in the exercise. And if you have any doubt, if you are not able to move with the next step, you can kindly refer this video again. You just see again what is the steps that has been carried out for the sums that have been given. If you don't understand, kindly text me in the comment section so that I will update that doubt in the next upcoming videos. Okay, so we will meet on the next class for exercise 1.3 of the same lesson. So till that, I am taking leave. Thank you.